There is a significant translation process that takes a basically English statement and then translates it into something that the computer can actually operate on. The intermediate step between that English-like query language that we use and the actual machine language that performs those instructions and operations is known as the query plan. It's a logical approach to how the cluster will accomplish what is going to be asked of it. Now you can access this plan via the explain statement. The information you get in a query plan refers to physical operations, not the logical aspects of the return result. So sometimes you'll see terms that you are familiar with, but you might be familiar with the logical representation of that action, not the actual physical action. This will become more clear as we proceed, but a quick example: the term left join describes a logical operation. You are taking two result sets, you're going to keep all of the rows on the left and then only the ones that match on the right. Now physically that might be accomplished by either a merge process, a hash process, or a nested loop to actually connect each set of data to each other. And we'll talk more in depth about that here in just a second. Now, when you do an explain, there are several categories of information that will describe the physical actions that you will find. You'll see information regarding scans, information regarding joins, aggregates, sorts, unions, intersects, and accepts. There are network operations. There's a collection of information points related to the data redistribution, that moving of data from one node to another. And then there's a whole bunch that we'll just label miscellaneous. And finally, you may from time to time also get alerts in your explain results. These alerts point out things like outdated statistics or operations that the engine knows could be improved. So let's explain each of these categories using actual queries from our Abaco sample data, and most of these are queries that we've already ran. For example, this query right here is the one that we use to show the benefit of including all the additional where predicates. If we take the one that just filters on $, that explain plan looks something like this. For most people, it's easiest to read the plan backwards. In other words, the first step listed in the plan as shown is actually the very last step taken by the engine right before returning a finalized data set to the end user. Each subsequent step is the action that preceded it. It's also important to realize that many of the steps may actually be happening in parallel. The explain output will line up planned steps that may operate in parallel. Now there are cases when they're not actually operating in parallel, but seeing where these actions are lined up is generally a good way to identify parallel operations. Okay, so right off the bat we do get one of those alerts that I was telling you about. It's informing us that one of the tables we're running this against may have outdated statistics. Specifically, it's saying dim currency and dim customer. Now, a couple of interesting things to point out about this plan. We see the hash statement being used a couple of times. A hash is basically when it takes a value and then gives it something that's easier to store and find in memory, a hash value. These are a one-for-one match, but it takes an entry that is very human readable and turns it into something that is very machine readable. It does these hashes so that it can perform the joins. You can see that here. It does a hash join on all the results that come beneath it. And specifically, it tells you what kind of data redistribution has to occur for this to happen. It's doing an inner join, and so it needs to move the data from the nodes where it finds that data onto a specific node where it can complete the join of all that data. That's that bcast. And you can see it has to do that a couple of times because we are joining multiple tables. Finally, it brings it all together in this step next to the end, and then it does a hash aggregate. This final hash aggregate is when it's taking each of the unique values, converting each unique combination into a hash value, and then summing up sales amount to return to the end user. So this was our query without that additional country region filter by the USA. If we add that additional filter and then rerun the explain, let's see what kind of effect it has on the query plan. So you now see that filter here. So let's point out a couple of things that you can look for. First, check for those alerts. Did it tell you to go get new statistics? And we did see that. Second, when it does scans on tables, what it's doing is it's going through an entire table and looking for values that match rows it's looking for. Does it have a filter? Because ultimately, when it has to return data from the individual node that it's searching through to either another node or even the leader node. If it has a filter, that's less data that's going to have to traverse those nodes all the way back to the end user. If you see a whole bunch of sequential scans or any kind of scan without filters, you're probably pushing more data back and forth between your nodes than you have to. Now look real closely here at these parentheses. You have a cost value and then a rows value. These are best guess estimates. This is all based on those statistics. So the better informed your statistics are, the closer these numbers are going to be. It's also important to realize that that cost is kind of an arbitrary number. It's a cost number that it assigns. Obviously, larger numbers means it has to do more operations, and it's probably going to take longer. When you're reading these query plans, each additional step is cumulative. So way up here at the top, you have the cost of all steps before it.